Okay, welcome back to COSC 2325. We're going to review some of the things that we talked about in the last video where we just used Visual Studio to code. We're going to go over some of those concepts and then start something new. So last time we went over data transfer instructions, transferring data with different types of instructions like MOV or moving with zero extension or signed extension. We also looked at addition and subtraction, so the add and the sub instructions, and we looked at data related operators and directives and indirect addressing. So let's start with our operand types. So as far as operand types, remember operands are like if you have MOV and then you have a register, comma, 5, you're moving 5 into a register, that's 2 operands. So MOV requires 2 operands. It requires the destination, like what you're moving into. So first of all, the source, what you're moving into the destination. So as far as operand types, we have immediate operands, and this would be a constant integer, and these constants would just be encoded with the instructions. So they're not saved in a memory location, they're not in a register. It's just a number 5 and the number 10, etc. And then another type of operand is a register. So one of those 2 operands in a move instruction can be a register name. The register name is converted to a number and then it's encoded within the instruction. And then we have a memory, which it is a variable. So the memory reference to a location in memory. The memory address is encoded with the instruction, and the register holds the address of a memory location. When you're looking at what operands your instructions can use, you're going to see these shortcuts, abbreviations. That's the right term. So if you're working with move, for example, move can have a reg, meaning you can move from register to register, or you can move from a variable, so it would be mem, so a variable would be mem, so memory to a register, or you can move you can move an immediate value into a register or a memory location. So these are just abbreviations that we would use to talk about what you can and cannot do when you are looking at different instructions and the operands that you can use on the right or the left side. So in this example here, it says direct memory operands. So a direct memory operand is a named reference to storage in memory. The name reference label is automatically referenced by the assembler. So this would be just a variable. So we have direct memory operand. So this is directly var1 access a memory location. So var1 is whatever values in var1, this 10h. This label here will take us to that memory location where this is found, where 10h, where 10 hexadecimal is found. Move here has 2 operands, so here we have register mem, register mem. This is an alternate format. We talked about the square brackets just being there to just to basically show, to make it more clear that this is a variable, but they're not required. The brackets are not required. We do like to use them a lot when we deal with arrays, and we'll look at that in a second. So in this example, var1 is defined as 8 bits, 1 byte, and the 10 hexadecimal stored in var1. var1 gets moved to the AL register. Remember that AL register is 8 bits. So I'm going to just draw this up here for a second. So we have the EAX register, EAX, and the EAX register is 32. So I would say from here all the way over here, it's 32 bits. And I'm just going to write 32 there, okay? Then if we cut this in half, this is 16 bits and 16 bits. So if we just reference the AX register, the AX register is over here. If you look at the register, you know, when you run your code in Visual Studio, you would see we saw that AX was over here. And then we could further divide AX. So AX is 16 bits. So if we define something that's the size of a word, then we could put it into the AX register because AX is 16, word is 16 bits. If we divide this in half, this here is 8 bits and this is 8 bits. This is the AH and this is AL register. This is 8 bits and this is 8 bits. Okay. So we moved var1 into AL because var1 is defined as a byte and a byte is 8 bits. If you try to put var1 into EAX or AX, it's going to give you an error. It won't let you assemble. It won't assemble. So it'll stop you before assembly happens. Move instruction. So just reviewing on the move instruction, this is the source, this is the destination. No more than one memory operands permitted, meaning I can do memory here and maybe move a register into memory, or I can put memory here, move memory into a register. CS, EIP, and IP cannot be the destination, so these registers cannot be the destinations. This register here points to the segment where a program that's running begins. So we definitely cannot overwrite that. And these are instruction pointers. So an instruction, a whole instruction that's coming in that needs to be executed by the central processing unit is, this is where we store where that instruction, or we point to that instruction. So we cannot mess with the instruction pointers. We cannot move, no immediate to segment moves. So let's take a look at this here. Count is a variable, memory location, right? So we can put count is 1 byte, which is 8 bits. BL is also 1 byte, so that's okay. We can move count to BL. WVal is size word, which is 16 bits. Word is 16 bits, so we can move 16 bits into AX because we said AX was 16 bits. Here AL is 8 bits. We can move AL into count, which is 8 bits, so 8 into 8. This one's going to give us an error because WVal is a word, which is 16 bits. So this is 16 bits. and this is 8 bits. So data size is not going to match, and it's going to give you that error before it assembles the entire program. Then count is a byte. AX is 16 bits or 2 bytes. So again, these do not match in size. And then this is 32 bits and count is 1 byte. Not going to work. 8 bits and 32 bits. So all these are different sizes. As far as moving, remember we cannot move. So when we move, we cannot move. We say move. A memory location into a memory location. So mem, we have a memory location here, comma, mem, and another memory location. It does not let us do that. That's a no-no. You have to move memory into a register first, and then do whatever else you want to do. Right, in this slide, you're going to look at these instructions and tell me why each of these move statements are invalid. Now this one here is supposed to have a V, that would be invalid because it doesn't have a V, but so pretend it has the V, it's something else that's invalid. And you can pause the video and then come back and then I'll go over it. So looking at this first one, the reason this one's invalid, so here we have an immediate value, and this immediate value of 45 is put into a register that we cannot write to. This register is the segment register, and remember the segment register points to the segment of data that's used by the running program. So we don't want to mess with that pointer, and that's why that one's invalid. This is a 32-bit register, WVAL. WVAL is a word size. Word is 16 bits. So this sizes do not match. So we have size mismatch right here. The EIP is the instruction pointer. We cannot write to the instruction pointer. So that's why this one is invalid. This one, we're moving a memory location, BVAL, this memory location, into an immediate value, so we can't do that. We can't move. Immediate value doesn't have a location, so we can't move a location to it. And then this last one, BVAL, is 1 byte. Okay, so here we have memory. So BVAL and BVAL2 are both memory locations, and we're not able to move memory to memory. We can only move memory to register, or register to memory, or we can move an immediate value into memory or into a register. Okay? So another instruction we looked at was a zero extension instruction, moving with zero extension. So when you copy, you can copy a smaller value into a larger destination, but you would either use move CX or move SX. The CX would just fill the upper half of the destination with zeros. So here we're moving this binary number into BL. BL is 8 bits. And then here we're moving 8 bits into 16 bits. So we're moving it to here, to these 16 bits. So all this right here, these bits get padded to 0 or filled in with 0. The destination must be a register. So with move CX, the only thing you can have here on the left-hand side, the destination, can only be a register, cannot be a memory location. Move XX is to fill the upper half of the destination with a copy of the source operand sign bit. So if you know that you have a sign number or that you could have a sign number, then use move SX so that when you because if you move it without that sign bit, it's not gonna read the correct value. So if this is the source, if this is what we're moving, and the sign bit is a 1, then it fills this with 1. If it has a 0 here, then it fills this with zeros. The destination also must be a register. We looked at the exchange instruction where we can exchange the values of 2 operands. Remember, this is 1 operand and 1 operand. At least one of the operands must be a register. No immediate operands are permitted. You cannot have constants here. So you can't have like AX and 5 because you're exchanging, you got to have these things that are here that you're exchanging in some kind of location. Either a register that holds values or a memory location. So I can have register, 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 variable register, register, register. So all we're doing with these is we're just exchanging the values. Notice that var1 here is word size, and so bx is word size. So it does have to be the same size. Here we have two 32-bit registers. Both of these memory and register are 16 bits. These are both 8 bits, and these are both 16-bit registers. This one causes an error because we're trying to exchange 2 variables. We're not able to exchange we can't have 2 variable operands in an exchange. Okay, direct offsetting. We looked at this also last time, and we coded some direct offsetting. So in this example, we have this array called array B, and it is an array that contains byte size data. So each of these separated by commas is 1 byte. So we have 1, 2, 3, 4 bytes. This is a 4-byte array. If you do 4 times 8, it's 32 bits. So this array contains 32 bits or 4 bytes. In this instruction, we're taking, so array B, we know that we saw last time that array B by itself just holds that 10 hexadecimal. To get to the 20, so when you define this, all that you see in memory for array B is a 10. To get to the 20, you have to add 1 to the name of the array. To get to the 30, you have to add 2. To get to the 40, you have to add 1, 2, 3. So this is array B. This is array B plus 1, array B plus 2, array B plus 3. Don't get confused. Array B plus 1 is not 10. Array B plus 1 is 20. Here it shows you that you can use the brackets or not use the brackets. We've always been used to using brackets with arrays, and it really just makes it more clear that this is an offset. So you'll see me use the brackets to make clear that it's an offset. So here it says the constant offset, this is the constant offset plus 1, is added to a data label, this is the data label, array B, to produce an effective address. Effective address, all that is saying is that it produces an address that gets you to some data. So this actually will get you an address where 20H or 20 hexadecimal lives. And array B plus 2 will give you the address of where 30 hexadecimal lives in memory. Remember that when you create arrays, the locations are adjacent to one another. They're right next to one another. So 10H, whatever that address is, right next to it is where 20H is, 1 byte away. And it's 1 byte away because you define it as a byte. If you define it as a word, it would be 2 bytes away. Okay. And here, the question is, why doesn't array B plus 1 produce 11H? Well, we're not adding the 1 to the 10. We're adding 1 to the address of where array is found. So we're not adding 1 to these numbers in here. That's what it's making sure that you understand. Okay, in this example, we have array W, which is size word, and I have array W drawn here, and then array D, double word, is drawn up here. So word means that we're going to, if we start our offset at 0, we'll have to add 2 bytes to get to the next element, and another 2 bytes, or 4 bytes to get to the third element, because word is 2 byte label. And then double word is 4, so to get, if we start 1 at offset 0 to get to the second element, we'd add 4, 8, we would add 8 to array D, to the name of the array, to get to the third element, and we'd add 12 to get to the last element. So the very first statement, the move statement, they're adding to array W, which is this one. So array W is here at this location where the 1000 is. So if you add 2, you get to the 2000, which is what it shows you here. 2000 is moved to AX. And then if we add array W again, array W gives us 1000, array W plus 4 gives us a 3000. We move to the third element. And then the last example, array D, is the top array. So array D gives us the 1, array D plus 4 gives us the value of 2. The 2 gets moved to EAX, and you'll see 2 hex in the register. Remember that you're going to see all the values in the register for a double word, and then you're just going to see the last the last half, the AX register. You'll see that for these 2 examples when you look at the register. So I suggest you type this and you run it and you look at the registers. And I'll have an example after this video. I'm going to have a video that shows you in Visual Studio how we can look at the registers, and we can also look at the memory locations for the arrays. Okay, this says write a program that rearranges the values of 3 double word values in the following array as 3, 1, 2. So we have this array, size double word, that contains 1, 2, 3, and we want to arrange it. We want to swap some values and arrange it in 3, 1, 2 format. So here I've just put, like, let's say that 1 starts at offset E0 and 2 starts at offset E4, and if 1 starts at offset E0, then 2 will be 4 bytes away and 3 will be 8 bytes away. So let's see if we can show. There we go. Step 1, copy the first value into EAX and exchange it with the value in the second position. So we're going to copy this first value into EAX and then exchange it with the value in E4. So here's the code for that. So we have to move array D, which gives us a 1, into EAX. So now EAX has a 1. And then array D plus 4 would be the 2, and that gets exchanged with EAX. So then the 2 will contain the 1, and EAX will contain the 2. Note that. Okay, so now we have 1, 1, 3, and the 2 is in EAX. So let's look at the next step. Okay, so remember that our goal is to have our array look like this, 3, 1, 2 in this order. And currently we have 1, 1, 3, and then 2 is in EAX. So we want to exchange these two. That puts the 2 where it needs to be. And then the 3 will be in EAX, and we can just put the 3 here in E0, and then we've got it. So let's look at those steps. Let's see here. There we go. Okay, so first step is array D plus 8. Remember, array D gets you here, right? Plus 8 gets you here to the 3. So we got to move that. We're going to exchange that 3 with the 2. So let's do that. Let me write that. If I can get a pencil here. Okay, so we're exchanging the 3 and the 2. So this is 3 now, and this is 2 now. So now the 1 and the 2 in the correct place. Now I just have to move the 3 into E0. So that's what this last step does. It moves EAX into array D. So EAX gets moved into array D, so this has a 3 now, and now it looks the same, where we have 3, 1, 2. We have it in the correct order. Okay, so that's one way that we can exchange and sort this array in that format. Okay, here we want to write a program that adds the following 3 bytes. So we're going to add 80 hex plus 66 hex plus A5 hex. So the first step is there's different ways you could do this, many different ways, but here's one solution. They take my bytes, which is the 80, and they move it to AL. Now remember that it's a byte, so it has to be the register AL. It cannot be AX, it cannot be EAX. So they move my bytes to AL, and then they add the 66 plus AL. AL has the 80, so these two get added together. And then now AL has the sum of these two, and so then AL gets added to the very last one, which is A5. You could move my bytes to, like they did here, to AL, and then move my bytes plus 1 to AH, and then add them together, and then add AL and my bytes plus 2. That could be another option. So move this to one register, move this to one register, add them together, and then take that sum and add it to the third one. It would just have one extra step. And I'm sure you can come up with other possibilities for adding these together. So when I do the video with Visual Studio, we'll also do adding an array, because you'll be needing that in the future. Okay, on this slide, I want you to look at the code and see if there's anything that is missing. So you can pause it, look at each step and see what's missing, and then unpause it. So here I'm going to start with moving my bytes into AX. We're doing pseudo extension because AX is 16 bits and my bytes is 8. So we're moving 8 into 16. So now AX has 80. And then we move my bytes plus 1. So we move the 66 into BX. But notice we're just doing a simple move without the CX. So we either need to, there's two ways we can fix this. One, we can move 0 into BX. So add a line above here and say MOV BX comma 0. Or we can just change this to CX. Then we add AX and BX. So we're adding 66 plus 80 because BX has 66. And then we move my bytes plus 2 into BX. So once again, we need to either change this to CX or move into BX as 0. So we can clear everything out and then we're going to add AX plus BX and get our total. So yes, there's something missing. Move 0 to BX before the move. So it's telling you to put it here, moving 0 here. I guess you only need to do it one time. Move into BX, move a 0 into BX, and then now it's zeroed out, and yeah, you don't have to do it again. Or you can just use CX on both of these, or at least one of them. Okay, so there's that one. So this is another way that we can add the 3 numbers. Okay, the next topic or the next section is going to be addition and subtraction. We're going to be doing using add, subtract, increment, decrement, and looking at the flags that get set. And I'm going to do that in a video using Visual Studio so we can look and see how the flags get set as we use those instructions. And also we're going to define an array and use address offsetting so that we can add the different values in the array and display those values. Not display them, but show them on the registers and memory address window. And do the exchange, okay, that we just looked at. Use the exchange instruction. Okay, I'll see you in the next video.